Assalamualaikum and a very good day to you all. In this video, I would like to share with you an introduction of probability. Okay, so there are some terms that I will introduce it to you with some definition, and then afterwards we will do 3 examples for each one of the term. How does it relate to each other? Yeah. Okay, so first thing first, the first term is random experiment. Okay, so the definition is an action or process that leads to one of several possible outcomes. Okay, so for example is if we roll a fair die. Okay, if you roll a fair die has has 6. If it's fair, then it has 6 equally possible to get each one of the face. Okay, it has number 1 in until 6, so the probability of getting 1, 2, 3, 4, 5 and 6 are all equally likely. Okay, so the probability of getting 1 or 2 or 3 or 4 or 5 or 6 is are the same. Okay, so a random experiment is one action. So we have fair die and we roll. That's the random experiment that we do. Okay, now how about outcome? Outcome is the result of an experiment or other situation involving uncertainty. Okay, what sort of result that we expect if we roll a fair die? Okay, so the outcomes, okay, there are so many outcomes. Okay, so it means that we get what we expect if we roll a fair die. So we might get 1, 2, 3, 4, 5 or 6. So that these are the outcomes. Okay, what happens? Okay, now so the sample space is the set of all possible outcomes of a random experiment. Okay, so we have the outcomes. The possible actually outcome and sample space more or less the same thing. Sometimes people get confused, but sample space is the proper version of it. So we usually write it with S. Why I cannot? Black. Sorry. Okay, now usually why so thick? Okay, usually we write like this, and then we open it. So it's either we getting 1 or 2 or 3 or 4 or 5 or 6, and then we close them. So for example, if we have an experiment whereby there's no outcome at all, and then the sample space should be like this. What example? Not really for this one. Example like this, or we do this symbol. Okay, these two means an empty set. Okay, empty set. We cannot put 0 inside. If you put 0, it means that the outcome is 0. Okay, but it's not. Okay, we are not getting number 0 if some experiment doesn't have any outcome. Okay, so yes. Okay, so that's it. Okay, now let's continue with event. Okay, what event? Event is a collection of one or more of the outcomes of an experiment. Okay, of the outcomes. Outcomes is the everything, and then a part of it is what we call event. So which is satisfy a given condition. So it means that event is subset of sample space. So event is the subset of sample space. Okay, so maybe usually we denote, or the textbook denote event with a letter. Okay, for example, A means getting even number. Getting even lah. Even number, even lah. Okay, and then next, the last one is probability. Now, what is probability? Probability, let A be the event sample space. This one. Okay, now the probability of A, the probability of getting even, PA, is defined as some definition lah. PA, okay, equals the number of outcomes in event A over the number of sample space. Now, for this one, okay, so we do in this box lah. Okay, so probability of A equals the number of A happening. The number of A happening, and then the number of sample space. Now, what is the number of even happening? So maybe I use red color over here. From 1, 2, 3, 4, 5, 6, which one is the even number? We might get 4, we might get 2, we might get 2, we might get 4, I see it another way around, okay? Or we might get 6. So in total, there are 3 possible outcomes in event A, in getting even number. And then we divide by the total of number sample space. Now, how many sample space we have over here? We have 6 of them. So 6, we simplify it, we get half. Okay, so this is the example we do right away. Okay, now let's consider the second example. Okay, the second example, what we expect. Take a ball from a basket with 1 red ball, 2 blue balls, and 3 green balls. Okay, now, wait, can. Okay, can. Okay, so, what is the outcomes? Okay, the outcomes is either we get the numbers, okay, the numbers until 6, or we get red balls, blue balls, and 1, 6. This is second example, I'm get confused. Okay, it's getting blue balls, red ball, or green ball. Okay, that is the possible outcomes. It's either we get blue, either we get red, or either we get green. Okay, now what is the sample space? Okay, the sample space is, okay, since there are 1 red ball, so only 1 red ball. I did not, 1 letter I, it means 1 red ball. Since there are 2 balls, 2 blue balls, so we use B for denoting blue balls. Okay, and then there are 3 green balls, so there are 3 G's inside the sample space. Okay, now let's consider B getting blue balls. Okay, getting blue balls. Now, what is the probability of getting B? Okay, so how many B's inside our sample space? 1, 2. So there are 2 possible possible balls that we might get. The first blue or the second blue. Okay. Now, how many divide by the number of sample space? How many sample space? 1, 2, 3, 4, 5, 6. Okay. So we simplify it, we get 1/3. So this is the probability of B. Okay. Now, let's upgrade. Let's upgrade by considering example 3. Now, what is example 3? Okay, what is the event? We roll, not event, what is the experiment? Okay, we roll a die and take a ball. Okay, we use the first example and the second example. Now, what is the outcome? What is the outcome? The outcome, we might get blue balls and 1 and the numbers lah, and 1 or 2 or 3 or 4 or 5 or 6. Okay, or we might get red balls, red ball, only one ball, and 1 or 2 or 3 or 4 or 5 or 6, or we might get green ball and 1 or 2 or 3 or 4 or 5 or 6. Okay, since we mix the outcomes, so therefore we mix the experiment, so the outcomes might be a little bit weird, just like this. Okay, so we have to list like that. Now, how about getting the sample space? Okay, the sample space is very big lah, if you ask me. Okay, now why? Because actually I can list it over here, but it is very confusing, so instead we do it over here. Okay, now how we do it? Okay, by representing them in a axis like this. Okay, so this one representing the numbers on the die, 4, 5, 6. So this is number of die. Okay, just in case if you're wondering why I keep saying die, 1 die, 2 dice. So that's the plural lah. Okay, now, so the x-axis down here, the horizontal, we use to represent the number of die, the number that you get lah. And then this is the balls. Okay, wait. Okay, so 1, 3, 4, 5, 6. Why I put 6? Because we have 1 blue balls, we have 2 red balls, R, and then we have 2 red balls. Is it 1 red ball? Oh, I'm sorry. 1 red ball, 2 blue balls, and then 3 green. Okay, green. Okay, so these are the possible combinations that we might get, because we throw a die and we take a ball. So this is the balls. Okay, balls in the bag. Okay, balls in the bag. So I'm going to fill up all this combination. So I pause the video for a while. Okay, so these are all the collection of sample space. You see, it's very it's like a coordinate of x and y. So as you can see, the S is very horrible. Okay, so we proceed with the experiment, with the event. Sorry. So let's consider the first the same event from example 1 and example 2, which is A, getting even, and B, getting blue ball. Okay, getting a blue ball. Now let's consider a new event, C, which the intersection of A and B. Okay, so how to get what is the probability? C is the probability of A intersect B. Okay, so maybe we circle in red the even ones. So which one are the even ones? So these are even, these are even. Okay, and we use the purple one, same color or different. Okay, I use purple for blue balls. Which one are blue balls? Blue balls are over here. I think, yes, blue balls are over here. So these are all the B's, and these 3 are all the A's. Okay, now what is the probability of C, which is the intersection of A and B? Now A and B, okay, so maybe P A intersect B. Okay, let's calculate the number of A intersect B. And then we divide by the number of sample space. What is the number of sample space? Just multiply 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 6, 6, 36 lah. So down here are all 36. Okay, over 36. Now we want to figure out this one. Intersection means it obeys both of the rules. So which one falls for both condition is the one that I circle in chocolate. This one in brown. Okay. This one, also this one, this one, this one. So how many are they? There are 6 of them. Okay. So we simplify it, we get 1/6. Okay. We can do the same thing for intersection as well. Okay. This one intersection, sorry. We can do for union as well. Okay. Let's say we change. Change this one, union. Okay. This one change. The S are just the same thing. Okay. Still 36. Okay. What does it mean by A union B? A union, unlike intersection. Intersection means must obey both of the condition, which is even and blue ball. This one union. Union means the union lah. Okay. As the name itself. Okay. It means that as long as the combination obey either one of them, we take. Okay, so from here, which one we are going to take? Okay, I use different color lah. So I use what color? Well, all the colors are not grey. Grey is this one, is it? More or less the same as blue, white. Okay lah, I still use brown, but I padam all this first. Allah. Okay, tak apa. So now on top of this brown, or the one already brown I circle, 6 of them. Okay. We are adding the ones that in A and B. Which means this one also take, this one also take, this one also take, another 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So total 18 1, 2, 3, 4, 5, 6, 7, 12. 12. This is 15. 2, 3. 12. 12. 9. Ya Allah. 12. 12. 18. 20. So total lah 24. Okay. So we simplify them. Alamak. 24, 36. Okay. It's 2/3. Okay, I think that's all. Enough lah, 20 minutes already. Okay, for introduction. Okay, I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.